Okay, good morning, guys. So today we're going to go ahead and work on inequalities again. Make sure you guys have a notebook where you're taking notes in. So inequalities we mentioned was the idea of not equals. And this sounds like a negative thing, but it actually is a positive thing. It gives us more opportunities to find more answers. Like the example is, if I say x is greater than 3, well, what numbers could be greater than 3? Here's my number line. And we illustrated that if this is 3, we draw a hollow to represent the inequality because it's not equal to, and numbers like 4, 5, 6, these are all greater than 3. So there's more than one answer that works here. And that's kind of cool. A slightly different answer, if I write x is greater than or equal to 3, we mentioned that this graph looks very similar to our greater than, strictly greater than, except at 3, we do a solid bubble. And that was a big difference because now we could be equal to 3. And we write this as this is greater than, x is greater than 3, and x is greater than or equal to 3. So we could sit on 3. 3 is an okay number for us. So we're going to go ahead and we're going to give you guys some problems, and you're going to tell me if this is a true statement or not a true statement. So right now, today, we're going to just learn to check inequalities. Oops, lost the E there. Check, oops. Yeah, inequalities. We're going to check inequalities. So my example is, if I tell you 2x plus 5 is greater than 10. Okay? Let's think of some numbers that will work. Would x equal to 1 be a true statement? Would x equal to 2 be a true statement? Would x equal to 3 be a true statement? Okay, so does it work? So if I plug in 1, 2 times 1 plus 5, is this greater than 10? 2 times 2 plus 5 is greater than 10? And is 2 times 3 plus 5 greater than 10? Two plus 1, no, 2 times 1 is 2, plus 1 is 7. 7 is not greater than 10. This is not true. 9, is 9 greater than 10? Nope, not true. Is 11 greater than 10? Yes, true. So not every number will give us a true statement, and we want to be able to check that, and it's really an easy process of just plugging in numbers. Let's do a version of this with a fraction. If I write x over 2 plus 3, is this less than, let's do 6. So let's start off with numbers like 10. X is 10, then x is 6, and then x is 4. So we actually plug in the x value in. Is 10 over 2 plus 3, is this going to be less than 6? Well, 10 divided by 2 is 5. 5 plus 3 is 8. Is 8 less than 6? 8 less than 6? That is not true. So remember, the way we read this is that this side is a smaller side than the open side. So 8 is smaller than 6. That doesn't make any sense at all. Reading backwards is 6 bigger than 8. 6 is not bigger than 8. This is not a true statement. Try the next one. 6 over 2 plus 3 is less than 6. 6 divided by 2 is 3. 3 plus 3 is 6. Is 6 less than 6? This is a trick question. Is 6 less than 6? 6 is not less than 6. 6 is equal to 6. This is not true. So we're being very specific on how we're wording this. 6 is not 6. Wait, 6 is not less than 6. They're equal, but one isn't less than the other. You guys ever see two little kids fighting for a toy, but the family has two toys? Like, why don't you go play with your toy? No, I want that one. It's the same toy. But in the kid's mind, they're not the same. I want what you have. Then 4 divided by 2 plus 3 less than 6. I want you guys to tell me if this is true or not true. True or not true. And you guys are going to do that by, in the participants section, please click yes for true, and not true, please click no. Great, thank you for participating. I see a clear set of answers, and you guys are saying that this is true. 5 is less than 6. Great. So in IXL, you guys will practice this just to make sure we're good with our basic order of operations, and if we can see if that statement is true or not true, okay? Now, the next part of this is we're going to solve for inequalities. We're going to solve for inequalities. This is kind of terrible writing. Let me rewrite that. We're going to solve for inequalities today. And we're going to do specifically addition, subtraction, and we're going to do multiplication and division. So our main steps, our main moves. So here's our first one. If I say x plus 3 is less than or equal to 5. So just like before, we want to get this as x by itself. Get x by itself, alone. Now, for x to be alone, I need to get rid of the 3. Now, what we can do with inequalities is we treat it like an equal sign. Just treat it like an equal sign. So if I write it just in my head, I'm thinking this is just like an equal sign. Well, we would just subtract 3 to both sides. And for the process of addition and subtraction, we do exactly that. X plus 3 less than 5, we minus 3 to both sides, just like we would do for a regular equal sign problem. Again, for addition and subtraction, and many multiplication and division problems, it's just the same move as we did before. This becomes x is less than 2. Remember, the idea of solving for x is to give us one solid answer that we can refer back to and say, this is x, this is x. Sorry, x is less than or equal to. Now, if the statement is true here, it will be true here. Okay? If the statement is true here, it will be true here, because these are equivalent statements. So what I'm going to do, I'm going to actually test this. Is this true? If you pick a number that's less than 1, sorry, less than 2. So if I say if x is equal to 1, does that work here? Because it sure does work here. Isn't 1 less than 2? Yes. Now if I plug into up here, is 1 plus 3 which is now 4, is 4 less than 5? Yes, it works. Pick another number that's less than 2. If x was 0, plug it in. 0 plus 3 is 3. 3 is less than 5? Yes, it works again. What I'm trying to get to is that no matter how ugly this might be, if we do our basic operations, our opposite operations, we can find an easy set of answers that will always make this a true statement. So like we did before, we're just going to solve it like we did before using our addition, subtraction, multiplication, division, and we can solve for an easy answer that is true all the time. True all the time. Let's do another one. If I say 8 plus x is greater than 4. Now, can you think of a number that would make this greater than 4? Mr. Code, 8 is bigger than 4 already. So doesn't all answers work? If I plug in 1, 2, 3, yeah, 8 plus 1, bigger than 4. 8 plus 2, bigger than 4. 8 plus 3, bigger than 4. Yeah. But there's a point where it stops working. So here's what we're going to do. We're going to go ahead and solve it like we said before. We're going to get x alone. So we're going to get rid of the 8. In our brains, we're saying we're solving for x. So we have to get rid of the 8. Solving for x, get rid of the 8. So we subtract 8 to both sides. And x is greater than negative 4. Let me draw this as a number line. I want you guys to visually see this. If this is 0, negative 4. Now, which way would be greater than negative 4? In the iExcel, you guys practice this a lot already. So this is hollow, and we're going to be greater, so we're going to be on the right. So I'm going to plug in a couple numbers and see if this still works. And answer here, negative 3, negative 2, 1, and 2. These are all on the right side. These are all larger than negative 4. This is my answer here. So as long as we're bigger than negative 4, our original statement will always be true. So let's try it. Let's try negative 3. 8 plus negative 3. Is this bigger than 4? Well, 8 plus negative 3, they cancel out to become 5. Isn't 5 greater than 4? Yep, worked. Let's try negative 2. 8 plus negative 2 is greater than 4. 8 plus negative, that's a negative 2. That becomes a 6. 6 is greater than 4. Yeah, works. But looking at my graph here, what if I pick negative 5? Well, Mr. Ko, that's not on the correct side. You're right, it's not the correct side, so it shouldn't work. 8 plus negative 5. Well, 8 minus 5 is 3. Is 3 greater than 4? Oh, it didn't work. No. And that's what we were saying. Any numbers less than negative 4 doesn't make this a true statement. So it doesn't work for our original problem. Okay, let's see some examples from multiplication and division. Now there is a rule for multiplication and division. So beware, beware. For multiplication and division, there's a special rule. Okay? And I want to demonstrate the rule, and then we'll describe what that rule is. So if I say, well, let's just do the problem first, an easy version, and we'll do a rule version, a rule breaker. Okay, 3x is less than 12. So in my mind, I'm solving for x, and I need to get rid of the 3. The 3 is attached to the x through multiplication. Whenever a number is next to a variable, it is multiplying. So we undo that by dividing. So we're going to divide both sides by 3. X is less than 4. Please notice that the sign has not changed. For addition, for subtraction, it has not changed. Even for this simple problem here, it has not changed. So we're saying that x is less than 4. Now, for us to double check, pick a number less than 4. Hey, let's try 3. Isn't 3 less than 4? Check it. Is 3 times 3 less than 12? And that's a true statement. We did a good job. Now over here, I'm going to give you guys the rule breaker, where things change up a little bit, okay? Now, if I write negative 3, x less than 12. Please take a look. That's a negative value now. Negative value. And this only applies to multiplication and division. So we are going to get rid of, we're solving for x, we're getting rid of the 3, just like what we did here. Same exact steps. The opposite of multiply by negative 3 is divide by negative 3. So let's go ahead and divide both sides by negative 3. Now, look at what I'm doing here. I'm bringing the negative across. I'm bringing the negative across. Whenever you bring a negative across through multiplication or division, we have a special rule. You must flip the inequality. You must flip the inequality now. X and 12 divided by 3 is 4, negative 4. You must flip the inequality. You must flip the inequality. Okay, this guy must flip. Do we flip it just because of addition or subtraction? Never for addition and subtraction. See, look here. Didn't we move a negative across? Move a negative across? No flip, no problem. Only when it comes to multiplication and division must you remember to flip that inequality. All right, so let's look at another problem here. And we're going to look at the normal version and then the flip version, if we have to flip or not. Here's my next problem. Let's do division. X divided by 5 is greater than 4. Okay. And on my next version, we'll say negative x over 5 is greater than 4. On my first problem here, we want to save the x, and we want to get rid of the 5. The opposite of divide by 5 is multiply 5 to both sides. Bam, gone. X is greater than 20. No change. So multiplication, division, no change. As long as we're not bringing over a negative sign. It's like you bringing the coronavirus over to my house. That's a no-no, okay? This is the coronavirus. Are we gonna move it into my house? Nope. So we have to have special precautions. You have to wear your mask. So for this problem here, what's the opposite of divide by 5 on the right side? Opposite of divide by 5 is to multiply, I'm gonna write a parentheses, by multiplying by a negative 5 to both sides. I'm gonna multiply a negative 5 to both sides. Now, why did I write a parentheses? If I didn't write a parentheses, wouldn't this look like over here, 4 minus 5? Doesn't this look like just a subtraction problem? So when we draw the parentheses, it makes it very clear that we are multiplying both sides by 5. Tell yourself, I'm multiplying both sides by negative 5. So you want to make that clear by drawing the parentheses. Math is an art form, and there's rules to this game. So let me ask you, what's 5 divided by 5? Those cancel out. And what's a negative and a negative? That becomes a positive x. On the right side, 4 times negative 5 is negative 20. We have to remember the rule. We have to flip the inequality. So a greater than becomes a less than. So why do we have to do that? It's because I brought a negative to the other side through multiplication or division. So let's write the rule now. If you multiply or divide across the inequality, so it has to be across by a negative, you must flip the inequality. Okay, that is a general rule. Now we're going to practice that today. So go ahead and sign into Schoology. Sign into Schoology, and you guys are going to go iExcel. You guys are going to practice the 2 assignments I've included there.